All right, yeah. Hello, everyone. Session of GDSC. Today we will be having a session on BigQuery for machine learning. Um, this is actually part of the machine learning track. So last time we kind of like covered the data proc and data engineering track. And today we'll be introducing BigQuery and also some of the basics of machine learning. So as part of the event timeline, today we are at the BigQuery ML info session. Our last lab, which was data engineering lab workshop, is dependent on the BigQuery itself. So today we are covering the BigQuery, and then we'll come back to the lab workshop. And with that, Sumit, yeah, you can take it away.
Thanks, Arshad. I will start sharing my screen now. All right. Today's session is going to be about introduction to machine learning and introduction to BigQuery. And as I understand, based on the survey that we conducted, there's a diverse background of all the community members. So we decided to keep the content for machine learning to be introductory for today's session. So if you already are aware of some of these concepts, please have some patience and bear with me as we advance towards more advanced concepts. All right, let's get right into it. So traditional programming is where you have an input and you create a program, you have certain set of rules and you try to get an output based on those set of rules. In machine learning, what we do is we are given with a set of input, we are given with a set of output. We try to come up with set of rules which satisfy that function, and such that in the future, if we get any similar inputs, we should be able to predict uh, appropriate outputs based on our created rules. So that's machine learning in short. If we were to represent machine learning in a Venn diagram, here's what it would look like. So there's a superset, there's a main set of artificial intelligence. Within that is a proper subset of machine learning, and within that is a proper subset of deep learning. Artificial intelligence can be artificial general intelligence or artificial narrow intelligence, uh, where any program that is able to solve a smart problem, we could consider it as artificial intelligence. It is a very broad domain. Machine learning is something where instead of a rule based method, we come up with a function that maps in such a way that the predictions are appropriate. Deep learning follows a neural network approach where more complex problems can be solved more efficiently. Data science intersects all of these, but it also has some other techniques like which are more on the analytical side of things. Going forward, when do we exactly decide when to use machine learning? So it could be used where we do not have previous expertise, but we have certain set of data and we create a system, let's say, for example, for an automatic speech recognition system, where we are trying to uh, decide what the user is speaking, or if we are trying to decode a large amount of data related to genomics, let's say, for example, DNA data. So in these cases, we would resort to using machine learning. When is it not useful? When it's a straightforward example. For example, we just need to calculate how much a person is earning based on his payroll. We wouldn't apply machine learning in such cases. All right, here is a very short video about what exactly is machine learning. I'm just going to try to play this. I don't think this video is playing right now on the screen. I'm just going to post the link of this in the chat. Okay. All right. Going forward. So there's a certain machine learning life cycle that needs to be followed, and it all begins with what are the needs of your user and what are the needs of the business. Keeping this in mind, we define an objective. Uh, so that's how we know how to proceed next. For example, if you want to predict which friends a user is likely to share his photos with, or if you want to suggest a recommendation of a certain set of products to a user based on his previous purchase history. So there's a certain machine learning process where we first do these initial steps. Then we collect the data, we clean the data, we explore the data, we pre-process the data, and then we train and test the model. We would not be getting, we will not be going too deep into the nitty-gritties of the entire process. But to understand here, we train the model by dividing the data into two sets, the training set and testing set. We train the data on the training set and we evaluate the data on the testing set. There are different types of evaluation metrics that we follow for different types of machine learning problems. That is how we decide how our model is performing on that particular data, and we extrapolate that to our understanding of how it would actually perform on unseen data. And you can see that there's a arrow that's going back to the third step and again on the first step, which shows that it is the entire machine learning process is supposed to be an iterative process wherein you try to refine or fine tune your machine learning models based on whatever evaluation you have come up with. Here's another video about ML idea to implementation. I am going to try to play this video. Okay, I don't believe that's happening again.
Yeah, I
So I'm
posted
just
the
going
link in the
to.
chat if you can try to click that and see if you can play in the browser.
The it has opened here in my browser, but I don't think. Is the audio audible?
No.
All right, I'll just post the link in the chat. All right. Going forward. So if we were to broadly divide machine learning into different types, this is what it would look like. There are more types other than the ones listed here, but for the scope of the introductory session, we're going to just talk about these few types. So supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Supervised learning is where you already know what label you're going to predict. What is the target variable that you're going to predict? Whereas in unsupervised learning, you do not know exactly what you're trying to predict, but you try to come up with similarities in on the existing data. To give an example of both of these, let's say our target variable is continuous in nature, which means it's a number, let's say in the range of 0 to 50. So that would be a continuous target variable. Uh, Examples of that would be regression, wherein you're trying to predict the price of the housing market. It may escalate, it may go down based on various different factors, and you're trying to predict the price of the house. For categorical target variable, let's talk about classification, where it could be a simple Your target variable could be a simple class like yes, no, 0, 1. It could be binary, it could be more than two. Uh, for example, let's talk about medical imaging, where you're looking at X-rays of a certain patient, and based on the X-rays, you're trying to uh, predict whether or not there are problematic spots on the X-rays or not. Another simple example is, let's say, uh, it's winter here in Buffalo, and you're trying to predict whether or not it's going to snow tomorrow. If yes, how much is it going to snow tomorrow? So whether or not you're trying to whether or not it will snow tomorrow is a classification problem. And if it does snow, how much will it snow? 3 feet, 2 feet, 4 feet of snow. So that's a regression problem. Going forward, in unsupervised learning, there's clustering, there's association. For example, you're trying to create segments of different customers based on their purchasing patterns, and you're trying to uh, create a marketing strategy, for example, which cater to those particular clusters of users. There's market basket analysis, wherein if you're going to a convenience store and you're buying two items, which are which you would usually buy together, it is understood that one would assume that, okay, this item goes well with the other item, so maybe we should place them together, or maybe we should maybe like we could create a deal for both of those bought together. So that's something along the lines of market basket analysis. I am not going to cover semi-supervised learning and reinforcement learning for the scope of BigQuery, but these are just some different types that I have listed here. Going forward, again, these are different ML use cases that one could encounter. So we have where do we start from? What are the different tasks? What are the different types of models that we could use, and examples of all of those tasks? So if you want to predict values, uh, there's an example of predicting sales figures, predicting stock prices. If you want to generate recommendations, so what kind of recommendation is it? Is it a product recommendation? Is it content recommendation based on users? If you're creating a recommendation system for a streaming platform, what has the user watched before? What genre of movies that person likes? You could create a recommendation system based on that. There's other different tasks like finding anomalies. Fraud detection is a very classic example of finding anomalies in your data, where you're trying to create a system which, based on historical data, will create a system which comes up with warnings whenever a fraudulent transaction is committed. There's also time series forecasting, where you're trying to predict different prices based on historical data. Some of the techniques for all these tasks are listed here. Going forward, these are a few slides that I have put in, where I have just put in what the task is and what type of machine learning we could be using for each of those. So if you're recommending what someone will download based on previous purchases, this is an example of following a pattern that the user has, and this would be a sequence prediction problem. Labeling an email as spam or not spam. So if it's spam, we would mark it as yes, it is spam, and if it's not, we would mark it as no. So it's like a binary classification problem. Identifying trends amongst a group of people who have bought a new music release. So we are basically looking for similarities and finding something in common based on various factors. For example, if a user maybe likes the country music genre, it's possible that that same user might also like folk music genre, and other such examples. So you could be creating clusters of these users and recommending certain products, certain uh, you could target these users based on whatever business objective you have. Captioning a video. So it's an example of style transfer where you are generating text for a video or a sequence of images describing the content of the images or video. Determining workout activity based on phone movement. So this is like a classification problem. So let's say you have an app in your phone which is trying to determine what you are currently doing based on how your phone is moving, whether you're walking, whether you're running, whether you're jumping, whether you're sitting in one place. And these types of machine learning problems are somewhat complex to design, in the sense that there are also certain adversarial uh, cases to such problems wherein you're carrying your phone within a car. So the car is moving, but you actually are not moving. You're moving within the car. So this is like an adversarial example. So the machine learning task has to determine whether what kind of activity you're doing. Predicting the strength of a password, it could be both a classification problem as well as a regression problem. For example, is your password strong? Yes or no? Whether it's weak, whether it's strong, that's a classification problem. If it is strong, how much strong is it? Is it stronger than, let's say, 50% of other passwords, 70% of other passwords? That's a regression problem. Suggesting spellings. So if you have misspelled a word, generally the words which are misspelled are clustered together. They are usually closer to the words that are actually spelled correctly. So it's even possible to create a spelling corrector using simple rule-based techniques, but it becomes complicated once you add more and more rules for these. Predicting the quality score for an advertisement, it's a simple regression problem. Estimating the arrival time based on time of day and traffic. During rush hours, it's possible that you are taking 2 hours to cover a certain distance, but if it's not a rush hour, it's possible you can cover the same distance within half the time. Translating between two languages, this is a style transfer problem. Let's say you are converting something that a person has written in the French language to the English language. Again, these type of problems can be complicated because, uh, for example, let's take you're converting something that's written in English to something that needs to be written in, let's say, Mandarin. So you might be aware that Mandarin language follows a pictorial script. So it does not actually have the same type of letters or even the syllables and the word structures that is followed in English languages. So these type of problems also fall under style transfer. Okay, so that was about the introduction to machine learning. What we are going to do today is the problem statement that we have at hand is you're going to use the Google Analytics sample dataset, and we're going to create a model where our dataset has several different features. Uh, we're going to create a model that predicts whether a website visitor will make a transaction or not. The features that we have are, of course, there's a target variable, whether a transaction was made or no. The total number of e-commerce transactions within a particular user session. If the transaction is null, then we could simply write the value of the data point as 0. Otherwise, we could set it to 1. So the way it works in BigQuery is all your target variables are aliased as label. If you want to alias it as something other than label, let's say in your data set, you already have a column which is named as label. you would you would not be able to use this alias. So there's are different methods that we're going to explore regarding this. Uh, the other independent features, the feature variables that we have are whether the operating system of the device that the user used for making that particular transaction, uh, whether that device was a mobile or was it a PC or was it a laptop. Uh, Based on the IP addresses of the user, we could determine in our data set we have the country from where the page was hit and how many times the page was viewed. So that's page views. We will be creating a simple logistic regression model using BigQuery. Okay, so this is the problem statement. Before we go on to actually doing the lab session, we will also be covering the introduction for BigQuery. Before we go to BigQuery, let's have a session, let's have a recap of the last session. So why are we using cloud? Because it offers auto scaling, it offers fault tolerance, the security aspect of your data is covered when you're storing your data, when you're using cloud services. We saw in the last session what is big data, what are the main characteristics of big data, and what are the ETL processes, that's extract, transform, and load. We learned about what a data warehouse is. We're going to, this term you're going to come across a lot when you're using BigQuery, because BigQuery is basically a fully managed data warehouse service. All right, so what are the challenges that we are facing? So businesses want to generate insights from their data. They want to look for patterns in the data to come up with new strategies to maintain or maybe even grow their business by making informed decisions. So that's where they're using machine learning. But the size of data keeps on increasing. It was estimated that there was 79 zettabytes of data that was generated in the year 2021 alone. So this large scale of data, it's difficult to uh, scale systems that can handle this data. And Google Cloud's enterprise solution for this challenge is BigQuery, wherein all these challenges are handled efficiently. Uh, for example, uh, the data replication part of the entire data warehouse ecosystem is handled by the Google servers. Okay, so I've already spoken about how highly scalable it is. It can work with data in the order of petabytes. What Google BigQuery does is it allows you to focus on the actual analysis of data instead of spending your time on designing the infrastructure to handle this scale of data. Uh, Google BigQuery is basically based on Dremel. Dremel is a scalable interactive query system developed by Google. It basically combines multi-level execution and columnar data layout, and it is possible to run over like billions of trillions of row tables of data and aggregate them, running complex queries within seconds. So Google BigQuery supports standard SQL, which is the ANSI standard. You do not necessarily need to have prior programming knowledge for working with Google BigQuery. And interaction with the model and data, it can be done using one of many techniques. Like there's the console interface, which comes on the Google UI, Google BigQuery UI. There's a command line tool if you are like a terminal person and you like to play with the terminal. uh, Developers and data scientists and anyone who wants to actually access all of these services using programming for their maybe third party application where you are just querying the data and training the models on BigQuery, but you want to show those results within your own applications. You could be using BigQuery's REST API and RPC, remote procedure calls for transforming and managing the data. It also has different drivers which you can easily integrate. So Google BigQuery solves the data silo problem. What is the data silo problem? Data silo problem occurs when you have independent teams uh, who have their own independent data marts, but the analysis of the entire data needs to come together as a whole. For example, let's say you there's a retail chain which has stores all across the US, and there are stores in each county in different states across different region, eastern region, western region, central region, northern region. So all of these have their own different control of how the data is stored. So to avoid the friction in data sharing and data version control, there's an identity and access control management provided by Google BigQuery, wherein you can create IAM roles, which is basically identity access management roles, wherein you are allowed to create access privileges for reading, writing for the data to uh, different sets of users, groups of users, or even groups of groups. So basically, your data is secured at a hierarchy. Google BigQuery has a simple pricing model where you just pay for the data storage and the streaming and search and querying data. Again, it's quite flexible because you only pay for whatever data you're storing, and you can decide on what strategy you want to use for your streaming and search and querying data. Loading and exporting data is free. Moving forward to the BigQuery pipeline, there are three main stages in the BigQuery pipeline. That's storage, ingestion, and querying. Uh, we're going to talk about each of these one by one. In the storage step, data is stored in a structured table. So standard SQL can be used for easy querying and data analysis. For example, data which represents sales of each store in the last couple of years. So as data variables scale to, let's say, thousands, managing it in one place becomes difficult. But Google BigQuery does it very efficiently. Let's say we want revenue broken up by multiple stores across an interval, or for a particular product across all stores. Uh, storing this data at different levels is possible using Google BigQuery. All of this is fully managed by Google, and the storage can be easily integrated with the rest of the GCP products, suite of products. BigQuery stores data using a storage format that is optimized for analytical queries, and it follows all the ACID properties of relational databases. Going forward, we have the ingestion step. All of this storage is not useful until and unless it is actually ingested into the BigQuery platform. You can upload your data in batch using the BigQuery UI, or you can upload using Google Storage buckets. You can also stream data into BigQuery using the Cloud Data Flow, or if you have data which is coming from multiple file formats, any of combination of different formats like CSV, JSON, Parquet, Avro, Data Store, Firestore. So you can use any number of combination of your input data sets uh, uh, and create them, ingest them into a single platform of BigQuery using data flow. You can also automate the ingestion of data. You could create schedules if you want to, like let's say periodically over time, your new data is coming up on a certain database weekly, and you want the data to automatically be ingested into your platform. It's possible to set up schedules for that. The third and the last step is where you want to actually start doing your machine learning work. All of this is possible using simple SQL queries, and you can create IAM roles where you can decide the access for what kind of data is accessible to which users. You can create views, you can share your analysis. And so basically, you can also, when I spoke about the three steps, it's possible to bypass the first two steps. If you are just learning about Google BigQuery, you can just bypass the first two steps and you can use the publicly available data sets and just begin querying to understand how BigQuery works. We'll be seeing all these three steps shortly in the lab session. Before that, I want to talk about what are the different supported models on Google BigQuery. You can do linear regression. Let's say if you want to forecast the sales of an item on a given day, and these labels are, let's say, real valued. I mean, they cannot be infinity or something like that. So you could like just simply use linear regression for that. You can have logistic regression, determining whether a customer will make a purchase or not. Uh, you can have multi-class logistic regression, wherein you have more than two classes in your classification, and a number of other supported models, including some very basic ones, some moderate ones, and also a few complicated ones like autoencoders, where you would probably use autoencoders for solving unsupervised anomaly detection or dimensionality reduction tasks in your data. Going forward, what are the advantages of using BigQuery? It helps in controlling costs, optimizing the query performance, and uh, I already spoke about the very flexible pricing model. It allows you to query up to 10 terabytes of data per month and 1 gigabyte in storage for free. About that is actually where you pay. Uh, it helps to democratize the use of ML by empowering data analysts, because so data analysts are the ones who actually play with the entire data, and they are the primary users of the data warehouse, and they play a main role in predictive analytics, which can help guide businesses in their decision making processes. It also increases the speed of model development and innovation by removing the need to export data. Instead, you can do all of it in a single place instead of exporting it. So there's the need to export your data into multiple formats and then again importing it for the next step is actually not very useful. It has certain disadvantages, with all of which are removed by Google BigQuery. Again, you do not necessarily need to have programming knowledge. You simply need to understand the basics of machine learning and need to have experience in using SQL. It allows for easy integration for your visualization, because that's how you will actually be conveying your results uh, to the actual stakeholders. There are easy integrations with BI tools like Looker Studio, Google Sheets, or even third-party tools like Tableau and Power BI. So basically, you are focusing on your data in the entire process instead of resource management. So it's a fully managed service. You do not need to set up or install anything. You do not even need a database admin for accessing the data. All of this is handled with access privileges. All you need is to simply log into your Google Cloud project from a web browser, and you're good to go. All right. So this is just an overview of what are the different services of Google Cloud Platform and where does BigQuery fit into all of this. So you can see that it has a major role to play in the big data part. And here you can see it also plays a significant role in the preparation and storage, and also in the actual analysis and machine learning. Okay. All right. So we will be starting with the lab session. I will hand over to Harshit now. Harshit, can you continue?
Yeah, sure. I just need to. Can you just like stop sharing? I need to share something.
Yep.
Oh, oh, oops. All right, yeah. So if you haven't already kind of like enabled your monthly subscription to Google Cloud Platform, these are the following steps. I'll go through all of these steps one by one. I've also shared these steps in the chat. So if you want to access these links, you can just refer the chat straight away. So first step is basically if you have already signed in your Google Cloud Skill Boost account, kindly log out of it. If you have already enrolled in the quest, please unenroll, and then follow this link in the browser. And once you actually follow this link, you need to go into the Kubernetes in the Google Cloud. That's the quest to enable your monthly subscription. And for today, the access code is this. It's only valid today. So if you're trying to actually use it tomorrow, it won't work. So it's highly encouraged that you do it today itself. Um, and then you need to go to the first lab, which is Introduction to Docker. Once you click on the Start lab, your 5 credits will be credited into your account. And once you end that lab, you'll have your monthly subscription. So let me just quickly go through all of these. So first you go to this link. It will take you to this particular page. So you need to scroll down at the end. And here you will find the quest, which is Kubernetes in the Google Cloud. So once you click on this, it asks for your access code. So just provide the access code which I shared for today. Then click on this button. Yeah, whatever this is. And then you need to just click submit. Once you click submit, you will be redirected to this quest, Kubernetes in the Google Cloud. I have already enrolled in this quest, so it's not enabled from, so that option is not here. But for you, you should be able to see that enroll in this quest blue button right over here. So click on that. And once you click on that, go to the first lab, which is Introduction to Docker. Once you go on to this lab, you need to click the Start Lab button. Once you click the Start Lab, it will give you the credentials to access the Google Cloud Platform. Just go through this lab. Once you do it, or maybe just spend some like 20 minutes on this lab. Once you do this lab and you click the End Lab button, you'll see your monthly subscription right in your account like this. Cool. So that's pretty much it for your monthly subscription. If you are facing any issues, do contact us. We are readily available and we'll be more than happy to actually assist you in any kind of problems that you're facing. Today we will be actually covering this quest, and the lab that we will be doing is getting started with BigQuery and machine learning. Sumit is gonna cover most of this. If you haven't already subscribed to our channels, these are all the channels. We have the Slack channel. This is a primary source of communication. So kindly join the Slack channel. I'll share all these links in the chat. Yeah, do join our LinkedIn and our Facebook and social media pages. We do have our YouTube channel. All our sessions are actually recorded, and you can find all our earlier sessions and whatever the sessions that are happening on this YouTube channel. And yeah, this is the GDSC UB official page. And with that, I think Sumedh can go ahead and start the lab.
Thanks, Harshit. I will share my screen again. All right. Uh, so, as I understand, we are almost nearing the end of our session. We have about 10 minutes of our planned session time remaining. So, we will be very quickly covering this lab. It's a very introductory session. This won't take This won't actually take 45 minutes of the time. And all of these instructions are actually written very precisely. So it will help you to complete this lab very easily. This BigQuery machine learning track has 5 different live sessions in it. This is the first one. We are going to cover the first session today. The next, second, and third sessions we are going to lab sessions we are going to cover in the next upcoming weeks. Uh, I hope everybody has their uh, cloud credits ready. If possible, try to do it along here with me. Okay, so just have some captcha verification. Okay, so once I have started the lab, there's an option for Open Google Console. There's a new username and password created for this session. What we will learn here is how to create, evaluate, and use machine learning model in BigQuery. If you recall from our presentation slides, I'll just open that very quickly, open that up. We're going to use the Google Analytics sample dataset for BigQuery to create a model that predicts whether a website visitor will make a transaction or not. Okay. All right. Uh, you do not actually need to do any setup. It's just you start a lab and open the Cloud Google Console. Okay. So here I will be putting in my username. I'll be putting in this password. Terms and conditions, I understand. Agree to the terms of service. So this is how the console looks like. And here we have our navigation menu on the left hand side. I'm just going to scroll it down. Click on more products. I need to search for BigQuery. So there's serverless, storage, databases, integration services, networking, operations, CI/CD, tools, analytics, and there it is, BigQuery. I'm going to click on BigQuery. Okay. Uh, so I also have this open here. These are just the steps that I'm following. First of all, I need to create a data set. So to create a data set, I can see my pinned projects here. Here I'm going to click create data set. This is the project ID. I need to give a dataset ID, which will be like a unique identifier. Let's name it BMQL lab. This. Okay. All right. Uh, it's possible to select a data location. Generally, you would select a data center location which is closer to where you are actually physically located. And here also you can also see the data centers which have like low carbon emissions. But for the purpose of this session, let's just select the first option, which is the default one. And there are certain advanced options. You do not need to go into those for now. And create dataset. So this dataset has been created. Okay. There's a progress bar here where you can just track all of these. Create a BigQuery dataset. Once you've created and you click here, you can track your progress. All right. So here we are. Here comes standard SQL. I am going to copy this over here, and then let's discuss what this query actually does. Create or replace model. This is the name of my project, BQML lab. Oh, okay. I have actually named my project something different. And this is the name of the model. Options model type is equal to logistic regression. This is where you are actually defining the type of model that it is. Here you are selecting the different columns that you're going to use: total transactions, operating system is mobile, geonetwork.country, total.page views. And here we are defining what is the target variable by defining it, by aliasing it as label. This is the publicly available from syntax for where the data set is available, and we are going to take this only between a certain interval of date, and we're going to limit it to this number. Okay, I have a syntax error over here. Unexpected end of script at 2:07. Okay, what have I done differently? I'm going to run this now. You can see the elapsed time over here in the execution details option. Meanwhile, there's a description of what all these columns are. And once this has completed its model creation, you can see what all types of graphs will be generated. It's still running. Here's the job information about this particular task that you're running. You can see the job ID, which user has created it, what is the location of the data center where this model will be stored, creation time, start time, end time. It's still running. So yeah, let's hold on. Okay, so it has completed. It took a total of 1 minute 52 seconds, and it completed 10 training iterations. You can see how the loss is gradually decreasing, which is what our objective is. We want the difference in the actual and predicted values to be as low as possible. So the loss is decreasing. This is the learning rate of the algorithm. Okay. We have trained this model, and I'm going to just tick mark that and go ahead. Now we can see the model information and training statistics. I'm going to click Go to Model. This has opened a new tab where different parameters that we use for training this model are listed over here. Actual iterations 10, different types of regularization which are used, just training techniques, early stopping, learning rate. This is what the table for each iteration looks like. So we can see at the 9th iteration, basically, so it's the 10th iteration basically, because it starts from 0. The training loss here is the minimum. The evaluation loss is also low. And these are certain evaluation metrics based on which we decide whether a model is good enough or not. We are primarily going to look at accuracy for this case, which is what are the total number of correct predictions based on the total number of predictions. And then there are some other metrics like precision recall, F1 score. There's a glossary of machine learning terms that is provided in the documentation. We're going to go through these in detail in the next session, upcoming sessions. I'll be linking that documentation here in the chat shortly. You can go through what each of these mean, but for now, let's just talk about accuracy. So here we got an accuracy of 0.99. Okay. Let us evaluate this model. I'm going to copy this piece of code. I will open a new editor and I'll paste it over here. Here, what we are doing differently is we are writing m1.evaluate. Previously, we had written in options, we had just selected what type of model we were using. Here, since we are going to evaluate, this is what the syntax looks like. I'm going to run this. Okay. So the data set was not found because I have named it differently from what the tutorial is. Okay. This is what has been printed over here. These are again the metrics. So on the training data, the accuracy was 99%. On my testing data, my accuracy is 98.54%. So I could say it's good enough. All right. Okay, so here you can see a machine learning glossary where we talk about each of these, what these metrics mean in detail, where, for example, precision is basically if your model predicted the positive class, so what percentage of the predictions were correct? Recall and the ROC curve, what is false positive rate, all of these things you can find here in the machine learning glossary. We'll be covering them in detail later in the upcoming labs. Okay, I've checked this. Now we're going to use the model to predict on data which it has not seen previously. I will create a new editor over here. I will paste this and run this. I need to change the dataset name. So what I am doing here is I am interested in getting the sum of purchases for the top 10 countries. So what are the top 10 countries which have the most purchases? So that's why I've done group by country, order by total predicted purchases, and sorted them in the descending order, limited to the top 10 entries. And you must have noticed that here we are doing m1.predict when we are actually predicting. In the previous case, we were doing m1.evaluate. So that's the main difference. Okay. Going forward, we have completed the step. Predicting purchases per user. I'm going to again copy this. Open a new editor. I'm going to run this. What I want to do over here is select the top 10 visitors, irrespective of their country. So I've not added the group by clause over here. for country. I've added it for full visitor ID. This particular user has made three purchases according to our prediction. Similarly, you can just use standard SQL to get to run any query you want based on our predictions. And so, yeah, it's pretty straightforward, all SQL. We've completed this step. Let's just test our understanding. These are just two questions. BigQuery is fully managed enterprise data warehouse that enables super fast SQL queries. That's true. Which option best describes the BigQuery ML? Creates machine learning models so you can export and use the model to reevaluate the accuracy of other models. We're not exporting anything, so this is not the correct answer. Exports data from the warehouse, reformats. We're not exporting, we're not reformatting anything. So again, this is not the option. Creates and executes machine learning models in BigQuery using standard SQL queries. This seems like the correct option. Creates machine learning models using programming. No, we're not doing this. So I'm going to click 3 and submit. All right, that's it. That's all. We've for the first lab session. We have finished the first quest, and there are. This was a very introductory lab session. It starts to get more complex, and we explore a few interesting use cases in the upcoming lab sessions. So once you're done, you can just end this lab. I'm going to give this 5. And yeah, that is it about this lab. I think I am done from my side. I will hand over to Harshit, and let me
Yeah,
just stop sharing.
cool. Thanks a lot, Sumit. I think yeah, we kind of like wrapped up the first session for Intro to Machine Learning and BigQuery. Next week we'll come back to the lab of data engineering, and moving ahead, we'll further work on the advanced lab of machine learning. And with that, I think we are pretty much done for the day. Thanks a lot for joining us, and yeah, see you next week.